A very good morning to you, sir. This is the CN video assignment, and the topic of our presentation is firewalls and VPNs. Our video is divided into two sections. First section will be VPNs covered by Krishna, Rakesh, Goyal, and the second section will be firewalls covered by me. So without any further delay, let's get started.
Hi, I'm Krishna Goyal from CSEB, registration number 179301101. This is the CN video assignment. My topic is VPN. When two people are having a private conversation, they expect it to be private to have confidentiality for what's said back and forth. Well, if we are sending sensitive information over our networks, we also want privacy and confidentiality for that information that we are sending back and forth. And one great tool that we can use to help enforce and provide confidentiality for data as it goes across our networks in a virtual private network or VPN. And that's what we are going to discuss right here in this video. So let's use this network topology as a backdrop for our conversation regarding virtual private networks. And let's imagine this site on the left here as the headquarters site, and over here we have the branch office, and we have got Rishabh right here at the headquarters site. And to get connectivity between the branch office and the headquarters site, they are leveraging the internet for connectivity. So when Rishabh sends packets in traffic to a server over at the branch office, that traffic would go something like this: through the routers, through the firewall, through the router, through the internet, and all the pieces there, and finally end up at the branch office at the server data. And the challenge is that if there's an eavesdropper anywhere in the path who is listening to the traffic there, they can copy the traffic, and if it's not protected with encryption, they can go ahead and make sense of the data. So if there's sensitive information going between Rishabh and the server of the branch office, we have just ruined the confidentiality because the eavesdropper now has access and can make sense of that data. So one of the solutions that we can use is to use encryption. But encryption is the concept of scrambling the data in such a fashion so that if anybody gets a hold of it without the right keys to unlock that data or decrypt that data, it's just a bunch of nonsense to the attacker or the eavesdropper on the internet eavesdropping on the traffic. If it's encrypted, they can't make sense of it, and it's no value to them. So the question might be, well, how do we make sure that all our traffic is encrypted? Well, we have a few options here. We have some applications. If we pulled out our smartphone and we are using a messaging app or some other app, it's very likely that individual applications are doing encryption before they are sending data back and forth between your mobile device and some other device. So the apps could implement encryption on their own. However, the problem is that that's not going to cover everything that's going in and out of our phone over, for example, a Wi-Fi connection. Suppose Rishabh with his mobile device opens up something that runs Telnet. Telnet is an application that can be used to remotely connect to another system, and it's not encrypted. So if Rishabh opens up a Telnet application that's not encrypted and he starts communicating over a network, that traffic is then subject to eavesdropping, and the attacker could learn sensitive information like username and passwords and anything like else that the attacker captured as Rishabh was communicating using a protocol, a set of rules that didn't include any type of confidentiality or encryption. So another answer to the question, how do we protect and encrypt everything, would be we could use a virtual private network. And with a virtual private network, everything that goes to the network adapter, once the VPN is turned on, everything is encrypted as it goes through. So if we wanted to provide confidentiality in encryption services between everybody at headquarter office when they talk to the branch office and vice versa, we could implement our virtual private network, and maybe we put it up the firewall so that is one end of the VPN tunnel. So the one end of the VPN tunnel, just to refer to as the path for the virtual private network, and to have the VPN tunnel go from the firewall all the way up to another device. Maybe they have another firewall up at the branch office up to here. So this VPN tunnel established between the firewall at headquarters and the firewall at the branch office. Now Rishabh over here, when he sends traffic, it would go through the switches, through the routers, hit the firewall. At that point, it would be encrypted and put into this logical VPN tunnel. This VPN path that goes between this firewall and that firewall, so anybody eavesdropping anywhere in the tunnel all they are going to get is nonsense because they don't understand how to decrypt the data. The eavesdropper is known, and then once it hits the firewall or at the branch office, the firewall there decrypt it and then it passes it on to its final destination. So if Rishabh is talking to a server that's going to be transparent to Rishabh, all Rishabh knows is that he's communicating with the server, and the firewalls are providing both ends of the tunnel for the encryption and decryption respectively. Now, this type of tunnel that's going between two sites, a branch office and headquarter site, it has a special type of name when we are connecting two sites together with a tunnel, and it's referred to as a site to site VPN. So, whenever we hear the term site to site VPN, it just means that there's two devices, one at each end between sites that are encrypting and decrypting the data. So it can securely cross over the network and not be vulnerable to eavesdroppers. But wait, there's more type of a virtual private network of VPN that we can build. It is referred as remote access VPN. It would go something like this. We have a user, and let's say that user is on the internet, and let's call that user Ram. So Ram is on the internet, maybe he's at his home or at a hotel, and Ram would like to access a server or some other resource at the headquarter site. But all he has is the internet to go ahead with and cross to get there. So we don't want to have Ram communicate blindly and be because then that traffic would be subject to eavesdroppers. So a solution that we could have Ram built a VPN from his computer and build his own VPN tunnel from his own location all the way to the edge of our network. In this case, we have a firewall acting as the head end device for the VPN. So Ram's computer would have a client or an application that could build that VPN tunnel from his device to the headquarter site, and then everything that goes between Ram and the headquarter site would all be encrypted and protected from eavesdropping because of that VPN tunnel. And when an individual computer could be a mobile device or a laptop when built when it is built using a VPN tunnel to a head inside that's referred to as remote access VPN. So the benefit is that we are protecting by encrypting all the traffic as it goes from Ram's machine through the VPN tunnel and his computer device all the way to the other end of the VPN tunnel in this example. So to sum it up, we have learned about a couple different types of VPNs and the value they bring to the table, and that is to encrypt data so anybody eavesdropping on the data won't be able to make sense of it, and that helps to keep our data secure. That's it from my side. Thank you.
In a race car, there are a lot of things that are going on, including where the driver is, where the engine is, and what if there's some kind of fire or explosion. So we want to protect our driver from the negative impact of the flames and explosion. And so for to do that, there's a firewall that goes between the two. Well, in the networks and security, we use the concept and technology of a firewall in several places, and in this section of video, I would like to tell you about a few uses and locations where we can use a firewall. Based on our topology here, an obvious location for a firewall would be on our network. So here we have a network-based firewall. Now this could be a physical device or it could be what's known as a virtualized machine or a VM. But whether it's a physical or virtual device, a firewall could provide many features to protect one part of our network and one part of our resources from another. So in this topology, this could be considered our trust for the stuff that we are trying to protect, and everything out there to the right can be considered untrusted or less trusted. And one element of firewall is just say no. We might ask the firewall, well, what are you saying no to? And the firewall could say, I say no to anything that is trying to come in from a less trusted location from the internet or from the office branch. If it is trying to come in, I'm just going to say no and drop the traffic. However, if we need to make exceptions to that, we can poke little holes in the firewall to allow just the types of traffic that we want to allow through our network, and perhaps that might include certain types of network traffic from the branch office going to our headquarters location, or perhaps certain types of traffic from internet users if that traffic is destined to our service. But generally speaking, the firewall is just going to say no. And that attitude of just saying no might cause a little bit of problem for a user, let's say Krishna, here at Computer 2. So if Krishna is going out to the internet, then one strategy we could use with a firewall is to allow traffic. If it's coming from our internal location, we will allow it to go ahead and go out. So if Krishna is going to his favorite server on the internet, and then the favorite server on the internet is then going to respond him back. But we yet have another problem, and that is the firewall is saying no, I'm not going to allow that reply coming back from that server to come back in. So that makes Krishna really very sad. So to solve that problem of Krishna not being able to get a response back from a server, most firewalls use a feature called stateful. And what stateful really means is we want the firewall to remember Krishna and that he went out. So stateful is remembering the state or the conversation that Krishna started as he went out to the internet resource. And by remembering the state when that internet resource replies back, when it's coming back in, if the reply traffic is perfect, it's lined up with exactly what the firewall expected as a response to Krishna's request, and it will allow that reply traffic to come back to Krishna, which makes Krishna now happy. So when someone refers to a stateful firewall, all they're referring to is a firewall that can remember the initial request that went through the firewall, like Krishna going out to the internet, and then firewall dynamically allowing that return traffic to come back because it remembers that initial request from Krishna and the reply is perfect. And when it goes to the features, as far as what we want the firewall able to do for us, so it can provide for us things such as URL filtering. From a company level, we can control the websites that Krishna is able to get to. So if Krishna is trying to go to site 1 or site 2 or site 3 because the traffic has to go through the firewall, and the firewall has a policy about what is allowed and what is not allowed, the firewall can say yes to certain websites in certain categories and no to others. We also may have very sensitive data and personal information at our organization that we do not want to be leaked out, like social security numbers, credit card numbers, and so on and so forth. Another feature firewalls can offer is called DLP. Now DLP is an acronym for data loss prevention. So if the firewall is looking out the traffic going through it, and if it sees stuff like credit card numbers or social security numbers, it can just say no, and they drop that traffic to prevent from being exfiltrated, which is a fancy word of saying leaked out of the network. Another fancy feature that many firewalls have the ability to do is analyze our traffic that is going through them and perform intrusion prevention and detection services. And because the firewall is between the two networks, if the firewall sees something that looks like an attack or malicious content, or whether virus related or malware related, or certain types of attacks that are trying to get into harm or internal networks, the firewall can just say no and drop that traffic and send an alert to indicate that event had just taken place. And as firewalls get fancier and fancier, there's a term for it, NGFW, for next generation firewall. So a next generation firewall has the ability to do these advanced features. Another term that's often used is UTM, which stands for Unified Threat Management, which can incorporate many features into one system. Another benefit of some of these next generation firewalls is that they have intelligence and learn information from the cloud. An example of using threat intelligence from a service in cloud would be if there's a new attack that's coming from some other country across the sea, and that attack has been identified by other sensors and other firewalls. That information regarding the block of IP addresses or the type of attack can be fed dynamically to our firewall, and that way the firewall with that threat intelligence, if it sees traffic coming from those source addresses, from those source locations, can start to drop it or at least put those on higher suspicion as far as packets before letting them go through the network. Now, one other aspect regarding firewalls is that a lot of companies have their service in the cloud. So if our servers out here, how do we get a firewall of some type between Krishna, the user, who is also on the internet, who is accessing our server, which is on the internet in the cloud? And the answer to that is we can use cloud services for our firewalls. We can use Web Application Firewall, WAF. That's the acronym there, and it would go something like this. If Krishna is the user and this is our server, I'll put a green here with a C, the cloud provider, and we have our traffic from Krishna go to the cloud provider who is doing the Web Application Firewall, all the filtering services, then that cloud provider can then forward the request. If it's approved and allowed over to our server, which can go ahead and respond back to Krishna. And with the firewall, once it's done putting something between, in this case it is putting the traffic between Krishna and the server, going through a web application firewall, making sure the traffic is okay. And one other aspect about firewalls is that we can also have firewalls on the local machines, and those are sometimes referred to as personal firewalls. And the attitude of a personal firewall could be, I'm not allowing any traffic into the system, says the software running as a personal firewall on this computer, unless it is a response to a request. So once again, if Krishna is going to a web server and reply comes back in personal firewall, can say, yep, I'm expecting that, where at the same time, if the traffic is from an attacker or somebody else that's trying to come to Krishna's computer, the firewall on that computer can say, you know what, I'm not expecting your call, you're not even going to respond to it, and it drops the traffic. So thank you for listening until the end. Have a good day.